Hello, period 4 and period 7. This video today is just going to be a review of two topics that we might very well come across on iStep next week. So we felt like in our honors classes we probably needed to review these really quickly since they don't really come up a whole lot in class. And that is the Pythagorean theorem and probability. So what I'm going to do in this video is a few examples of each thing, Pythagorean theorem and probability, and then you'll have an assignment tonight over them just to make sure that we can say that we've reviewed those two topics. Alright, so let's begin with Pythagorean theorem. So the first thing that we need to talk about when we are looking at Pythagorean theorem is we should know that it only involves one shape. And that shape is a triangle, but not only a triangle, it has to be a right triangle. And how do you know if a triangle is a right triangle? Well, one of the angles has to be a right angle. So the Pythagorean theorem is only for right triangles. Alright, the Pythagorean theorem says a squared plus b squared equals c squared. And the point of needing to have the Pythagorean theorem is so that if we have a right triangle and we know two of the sides of a right triangle, we would be able to find the third side that's missing by using the Pythagorean theorem. In the Pythagorean theorem, let's review very quickly. In my right triangle, each side of the triangle has a name. The two sides that make up the right angle are called the legs. And the third side, which is opposite the right angle, that one is called the hypotenuse. Now, in the formula, a squared plus b squared equals c squared, you also need to know which of those is the legs and which is the hypotenuse. Well, the legs are always going to be a and b, and those can interchange. You can have b on the left one and a on the bottom one, but the hypotenuse is always c. Okay, the hypotenuse of a right triangle is always the special side, it's the longest side. Okay, now if I ask some students which side is always the hypotenuse, they would say it's the diagonal side, but that's not necessarily true. What you need to know about the hypotenuse is it is the longest side. Alright, so what may we have to do with the Pythagorean theorem? Well, if I give you a right triangle, and sometimes I'll actually give you a picture of it, I might say that this side is 6 inches, this side is 9 inches, and we want to find the other side. Alright, so since I know it's a right triangle, and I know it because there's a right angle in the bottom left-hand corner, I know this is a right triangle, so I know that I'm going to use the Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared. Alright, so let's see here. The 6 and the 9 are the two sides that make up the right angles, so those have to be a and b, which means the side I'm looking for is c, the hypotenuse. So when I plug my numbers in, this is what I get. I get 9 squared plus 6 squared equals c squared. Okay, so now I'm going to start doing the math. I get 9 squared is 81. 6 squared is 36, and then of course c squared. 81 plus 36 is 117 equals c squared. Now, we never just want c squared, we want c. So when you have c squared, how are you going to get c? This is where the square root comes in. We're going to take the square root of both sides. And when I take the square root of 117, on the iStep, they may want you to calculate it to the nearest tenth, the nearest hundredth. They may say leave it in square root form. It just kind of depends on what is asked of you. If they ask you to calculate it, you're going to use your calculator and you're going to find the square root of 117, which is not a perfect square root. And when I just did the square root of 117, I got something like 10.81. So the answer to the nearest tenth is 10.8 inches. Now, on iStep, they could say, what is the whole number it's closest to, or what two whole numbers does it fall in between? If they did that, let's see here. The closest whole number would be 11 inches. What two whole numbers does it fall in between? 10 and 11 inches. So it just kind of depends on what they actually ask you. But in the meantime, the answer to this problem is C is 10.8 inches for what we are doing. Okay, let's do another one. Okay, on this one, let's see here. I'm going to say this side is 22 feet. This side is 8 feet. And I'm finding this side. Okay, so again, we know we have a right triangle. So I'm going to write my formula, a squared plus b squared equals c squared. Alright, so which sides do I know? Well, the two sides that make up the right angle are A and B. So let's make this A and let's make this B. And then the side opposite the right angle is C. So this time I'm not finding the hypotenuse, I'm finding one of the legs. So when I plug in my information, I get A squared plus 8 squared equals 22 squared. Alright, so when I start doing the math, I have A squared plus 64 equals 22 squared is 484. Alright, so now I'm going to solve this equation. So I subtract 64 from both sides. And we get A squared equals 420. Alright, take the square root of both sides. And again, let's find it to the nearest tenth. When I calculated it, on the calculator it came out to be something like 20.49. So to the nearest tenth, that would be 20.5 feet. Okay, so that's just kind of a little brief refresher course of what the Pythagorean theorem is. All right, now we're going to talk about probability, do a little refresher course on probability. And we're going to talk about two different kinds of probability. We're going to talk about independent probability and dependent probability. And you have to know the difference between those two because that makes a difference on how you actually solve the problems. Independent probability is we're going to be talking about events that are happening that are not going to affect each other. For example, if you flipped a coin and you spun a spinner, those two are not going to affect each other, so that would be called independent probability. Another example of this would be if we rolled a die and we picked a marble out of a bag. Those two are not going to affect each other, but they could happen at the same time, but they're not going to affect each other, so they're independent. Another example of independent probability would be, let's say I have a bag of marbles, and I'm going to choose a marble out, and then what's going to happen is on my second choice, instead of putting the marble back in the bag, or instead of keeping the marble out that I just chose, I'm going to put it back in the bag. So the first choice of marble does not affect the second choice of marbles. That would be independent probability. Dependent probability would be something where whatever I do in the first event, it affects the second event. An example of this would be if I have, again, a bag of marbles, and the first choice I pick out a marble, and the second choice, I don't put the original marble back in. My second choice, I pick a marble out of the bag, and what happened was the amount of marbles in the bag is actually one less. So the second choice of marbles affected the first choice of marbles. Now I know that's not going to make any sense yet until you actually see some examples. So let's begin. Alright, so the first example is we're going to roll a 6-sided dice, just a normal number cube, and we're going to flip a coin. We want to know what's the probability of getting a 3 on the number cube and a head on the coin. Okay, so if I think about a 6-sided number cube, a regular dice, how many 3s are on it? Well, there's only one 3, and how many possibilities are there? There's 6 sides. So the probability of getting a 3 on a number cube is 1/6. Alright, now, what's the probability of getting a head on the coin? Well, there's only one head on the coin, and there's 2 possibilities. So the probability of getting a head on the coin is 1/2. And what am I going to do with these two fractions? In probability, you always multiply. So the probability is 1/12. So the probability of rolling a 6-sided number cube and getting a 3 on the cube and flipping a coin and getting a head on the coin, the probability is 1/12. Okay, so this time we have a spinner that's numbered 1 through 8, and we have a number cube that's numbered 1 through 6. We want to know what's the probability of getting an even number on the spinner and a number greater than 2 on the number cube. What's the probability of doing those two things? Alright, so on the spinner, an even number on the spinner. Well, the even numbers on the spinner are 2, 4, 6, and 8, so there's 4 possibilities. And how many actual possibilities are on the spinner? Well, there's 8. So we have 4/8 of a chance of getting an even number on the spinner, which of course that simplifies to 1/2. Alright, what's the probability of getting something greater than a 2 on the number cube? Well, greater than 2 would be 3, 4, 5, 6. So that would be 4 possibilities out of 6. So there's 4/6 of a chance of getting a number greater than 2 on the number cube, and that reduces to 2/3. So now I have to take 1/2 times 2/3, and I reduce if I can, and I get the probability is 1/3. So we have a 1/3 probability of getting an even number on the spinner and greater than 2 on the number cube. Now those first two examples I just showed you, those are called independent probability. The first thing that we did not affect the second thing. Okay, so now we have a bag of marbles, and in this bag we have 3 blue marbles, 2 yellow marbles, 4 red marbles, and 1 white marble. We want to know what's the probability of picking out a blue marble the first time and then a yellow marble the second time. And this with replacement means after we pick out the first marble, we're going to actually put it back in before we choose our second marble. So this is again is an example of independent probability, because since I'm replacing the first choice of marbles back in the bag before I take out the second marble, I'm not affecting the first, or the second choice isn't affected by the first one. So this is still independent probability. Alright, so the probability of getting a blue one the first time. Well, there's 3 blues in the bag, and there's a total of 10 marbles in the bag. So there's a probability of 3/10 of picking out a blue one the first time. Alright, now we take that first marble, we put it back in the bag. What's the probability now of picking out a yellow marble? Well, it's going to be 2, because there's 2 yellow in the bag, and there's still 10 marbles in the bag. So it is 2/10 of choosing a yellow marble. Alright, so I'm going to take these two and I'm going to multiply them. 3/10 times 2/10. And I believe we get 3/50. So there's 3/50 of a probability of picking out a blue marble the first time, a yellow marble the second time, because we are replacing the first original marble that we chose. Now, we're going to talk the same bag, we're just going to change the problem. Okay, so now what's the probability of picking out a red marble and a red marble? And again, we're going to still replace that first choice. Alright, so what's the probability of picking a red one the first time? Well, there's 4 red and there's 10 marbles in the bag, so it's 4/10. Alright, that first marble we chose, we put it right back in the bag. So what's the probability of picking a red the second time? It's still 4/10. Alright, let's see here. We can do some reducing here. This is 2/5 and this is 2/5. So it's 4/25. So we have 4/25 probability of picking a red and a red marble after we replace the first one. Okay, new scenario. We have a bag of marbles, 3 red, 6 blue, 2 yellow, 4 green. And we want to know what's the probability of picking a green marble, then a yellow marble. But this time, after we choose the first marble, we're going to put it we're not going to put it back in the bag this time. All right, so here's what this means. This is actually dependent probability now because our second choice is affecting our first choice. All right, so what's probability of picking out a green? So this is just the same as last time. There's 4 green in the bag. And how many total are in the bag? 9, 11, 15 marbles. So to pick out a green the first time, we have 4/15 probability. Okay, so the first marble we take out, we're going to assume it's green and we're going to keep it out. We're not going to put it back in. So what's probability of picking out a yellow the second time? Well, we didn't pick out a yellow the first time, so there's still 2 yellows in the bag. But now, because we took out that first marble and we kept it out, instead of 15 marbles in the bag, there's 14 marbles in the bag. So we have 4/15 times 2/14. All right, so now we're going to do the math. And we're going to reduce. This is 2, this is 7, and I think that's all we can do. 2 times 2 is 4, and 15 times 7 is 105. So we have 4 over 105 chance probability of picking a green and then a yellow without replacing our first marble. Okay? All right, so I'm going to erase what I just wrote here. All right, next situation. All right, this time we have 4 red marbles in our bag, 2 blue, 3 yellow, and 6 green. What's probability of picking out a blue marble the first time and a blue marble the second time, again, without replacing our first choice? All right, so picking out a blue one the first time would be 2, because there's 2 blue, out of, let's see, 4 and 2 is 6 plus 3 is 9 plus 6 is 15. So 2/15 of picking a blue the first time. All right, now my second choice, remember the first choice we're going to keep out, and the first choice was a blue. So what's probability of picking out a blue one the second time? Well, because the first one was blue, with that the amount of blue goes down by 1. So now there's only 1 blue in the bag, and of course there's 14 marbles in the bag because that one we picked out is no longer in there. Okay, so we have 2/15 times 1/14. All right, when we simplify, 2 goes into 14 7 times, and we get here, we get 1 over 105. Okay? All right, so hopefully with all of this information I just showed you on the Pythagorean theorem and probability, that will help you do your assignment tonight. So you need to ask the sub now for your assignment, and you need to start working on it. And again, you can always watch this video more if you need to as you're actually doing your homework. See you guys tomorrow. Have a good night.